We're going to be looking at the area of a parallelogram in this video. And there are some different misconceptions that people tend to make when they're trying to find the area of a parallelogram. The first one would be to panic and to look at it and just think, actually, it looks like a really complex shape. How do I find that out? The other common mistake would be to multiply these two lengths together, so 6 centimetres by 3.5 centimetres. That's not how you find the area of a parallelogram either, and I'm going to show you why. Now you'll notice that if we look at this parallelogram, we can actually trim this part of the shape off. And that's going to give me a triangle, which I'm going to shade in, because we're going to cut it off. Okay? And then what we do is we can actually take this triangle and add exactly the same triangle onto this bit of the parallelogram. Okay? And so if I shade that in just to show that we've moved one from here to the other, what we should be able to see now is that if we forget this bit of the parallelogram and we add this triangle in here, we've got a rectangle. And so that means that this length up the top must also be 6 centimetres. Now we should know that to find the area of a rectangle, we do the length times by the width, and we can use exactly that same principle here to find the area of the parallelogram. We already know what the height is of the parallelogram, it's 3 centimetres, and we know that its width is 6 centimetres. So to find the area of the parallelogram, it's essentially going to be the base times by the height. And that's going to leave me with 6 centimetres multiplied by 3 centimetres, which gives me a total of 18. And remember, because it's area, our units are going to be centimetres squared. And so our answer for the area of a parallelogram in this particular shape would be 18 centimetres squared.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.